Alright, hello, and welcome back to my 2D Left 4 Dead little thing in Unity tutorial. Today, after something like 5 episodes, we're finally getting on to the actual infected. So, as you can see, we got identical, but these are actually infected. As you can see in the little, what's the word, hierarchy. Let's maximise this. So, we got them, we can shoot them, and we'll sort of attract their attention if they're nearby. And if we go here, when we're nearby, they'll attack us and stuff, and we just shoot them and they die. And if we break line of sight, they will use a path. But if they have line of sight, they'll just move in a straight line. And we can also do other ways to disturb them. So even if we don't shoot, we can bump them, and they will get there. That will attract them. And yeah, and if we don't have to touch them, but if we just move in front of them, so they can see us, they will get attracted to us. And some weird zombie fetishistics. Okay, I can't pronounce fetish. Fuck it, never mind. But they get attracted to us and they will come and attack us. Okay, so that's basically what we're doing today. Okay, so first up is just a quick bug fix, or 2 bug fixes actually. The first is that we've added a boolean for whether a weapon is a pistol or not. Basically, that's because if you didn't have a primary weapon and you pressed E, it would allow you to pick up the pistol and have it in that you were already carrying and have it in your primary slot. So basically, for when we are trying to pick up pistols, if basically the current weapon that it's looking at is a pistol, or its parent is not equal to null. So if the weapon is either a pistol, or if it's already held by a player, then we just continue because we can't do anything with it. Eventually, I'll get rid of this bit because we'll need to be able to pick up pistols due to having akimbo pistols. But for now, that'll just fix a bug and it'll be alright. And the second thing is, thanks to watching Alex Rose's live streams, he is a bloke who made Super Rude Bear Resurrection, which is a hardcore platformer thing where you die a lot as a bear in a hat. Yeah, I'm not into platformers, but he's quite good at game dev stuff, so he basically told me that, what's the word? You shouldn't use transform.translate, if I can find where I was doing it. You should use rigid bodies to move your shit if it's going to have collisions, because if you use transform.translate, it'll just sort of break and stuff. So I've done that. So now for the person movement, instead of using transform.translate for moving direction, we instead set my velocity here. So basically we just set, it's basically the same thing, so we just do direction multiplied by movement speed for it. And yeah, and we have a couple of new variables called my velocity, which is just a vector 2, and velocity stop timer, which is 0.1. And basically how it works is, when you call movement direction, it sets my velocity to be the direction multiplied by the movement speed of whatever object you move in. Sorry. And then, on the fixed update, so how to explain this? Fixed update basically is an update that controls all the physics. So it's not called every frame, but I think it can sometimes be called more than once per frame, if you get that. I think it's called before update and late update. So yeah. So this is where all your physicsy stuff should be. We basically just call set velocity. So what this does is applies the my velocity that we got from the moving direction calls to the rigid body, and that will basically give us the same effect as transform.translate in that it moves in the direction. But that brings us to the issue that once we stop calling moving direction, then the rigid body will still have the velocity. So in order to counter that, we've added this new countdown velocity stop timer, which basically just has a float for 0.1. And in this countdown velocity stop timer, if the velocity stop timer is more than 0, we count down. If it's less than or equal to 0, we set my velocity to be vector 3.0. So, and then on the next fixed update, that'll say, all right, we want a velocity of 0, 0. So we stop moving. And yeah, and for velocity stop timer, that is basically set to 0.1 each time moving direction is called. So basically this gives us the effect of while moving direction is being called, velocity will sort of be whatever will be the correct value. But as soon as we stop calling this, it'll assume, all right, we want to stop now, the movement, because we're not calling it anymore. And yeah. And I've also added a little thing called move to position. So basically, instead of just passing in a direction, we can just pass in like a position we want to move to. So say we pass in the player's position, and it'll basically just call our moving direction and work out the direction we need to move to get from the current position of this object to the position passed in, and just call it not normalized. Simple. So those were the two fixes we had to make. Now on to the new stuff. Okay, so this is the meat of the episode. It's the infected behavior script, which is added to basically just our infected test. So instead of having the player control input, we just have the infected behavior here, and a new infected health script that I've added. Just checking that. Yeah, that's fine. And okay, so first off, we've just got a public bool, say whether we're alerted or not. So if we're alerted is false, we're just idle. Otherwise, we are, trying to attack a player. Person movement script, just same really. We just needed to move the object. Pardon me. We've got a list of vector frees for the current path. Like I explained basically it just gets a path from the A-start algorithm that we implemented a couple of episodes ago. So that'll be the path to the current player that it's trying to pursue. Counter to say how far along that path we are if we are trying to follow it to the player, and a public game object for the current player we are trying to pursue. We've got a boolean to say whether we are currently trying to attack a player or not, and a float for an attack timer. So each attack takes 1 second because we have like a 1 second animation, so that's how it links up. And finally, our animator for the infected, which basically controls the animations, of which we only have 3, so it's not too complex. Right, so first off, in Awake, we just initialize stuff, so the person movement controller and the animator. On start, we add this infected behavior instance to our infected monitor. Basically what this is just a script that stores a list of all the infected in the level. So when we fire a bullet, we have a reference to all of them, so we can just call for each of them, are we in range to hear this gunshot and be disturbed by it? So yeah, I'll get to that in a minute. Okay, so first off, on update, we check if infected alerted is false, then we call is infected able to view player. So let's go to that. What we do for this is we go for each player, basically, in the world, using this player monitor class that we created this episode. Basically what this does is it controls all the players. It stores all the players in an array. So I'm eventually planning to add a split screen, not proper online multiplayer because I can't do that, but I would like to have a go at split screen. So that's why we store it in an array, and we go through each of them, and basically we work out the heading between the direction that the player is in comparison to the infected. And basically, if this value is more than 0, then that means we are in front of the infected. So we're going to assume that means the infected can see the player. And then we check if we have a line of sight to this object. Basically, what we do for line of sight to the object, it returns a boolean, and it takes in a game object and basically just tries to draw a ray cast to the object passed in. Okay, so basically we get the direction by start. Okay, sorry, getting ahead of himself. The raycast starts at the infected's position, the direction is the object's passed in position minus this transformed position. The length of the raycast is the distance between this and the object passed in. And we have a layer mask minus infected. This is basically just a public layer mask that we've declared here. So layers minus infected. What this basically is you can say which layers the rate. Basically, you can specify which layers you want the raycast to hit and which you want them to ignore. So in this case, we have our infected on their own separate thing. So we got 2 new layers for this episode. We've got infected and projectile. And what this allows us to do is that basically infected can sort of see through other infected. So it's not just going to block off other infected by having a large clump of them. They'll all be able to sort of swarm the player, horde style in Left 4 Dead. So that is why we have the layer mask there. Basically, after that, if you don't hit anything, we return false. Else, if the ray.collider is not equal to null, then if the object we hit is equal to the actual game object we passed in that we were trying to hit, then we return true and set the target to be equal to that game object. Otherwise, we just return false, either here, or if the ray.collider was null, then just return false. And that's that. And then, so assuming we have line of sight to this game object after we've checked it or something. Yeah. So if we have line of sight to a player instance, then we can check, has the target been disturbed? So if the basically if the game object is within 10 units of the player or the infected, then I'll actually just go over it in the actual method. Does that make more sense? Where is it? It's right there. Sorry. Okay, so basically this is a method to work out whether the infected has been disturbed. So we take a position of a disturbance, the maximum range of the disturbance, so things like gunshots, explosions, these can all disturb infected in Left 4 Dead, but they'll have different ranges, and you can have to say if you had the suppressed Mach 10 from Left 4 Dead 2, then that might have less range than say the grenade launcher or some shit. I don't know. And finally, we've got the source of the disturbance. So instead of passing in the actual gun, you just pass in the player. So this is what that actually fired the weapon. Sorry, not being very articulate today. Whatever. So, yeah. So if the infected is already alerted, then we don't need to do anything with that. So we just return false. We just return normally, sorry. And if we are within the range of a disturbance, then we set the target to be the source of the disturbance and set infected alert to true. And yeah, that's about it. And so by now, we've covered this bit. So that's the state, what the infected is in when it's idle and it's trying to find someone to attack or some shit, or checking whether it's been detected by, oh yeah, it can detect a player. So next up, so if alerted is true, so we do another check to see if we have a line of sight to the target. So if we do have a line of sight to the target, then what we basically do is we check if we are within 1 unit of the player. If we're more than 1 unit away from the player, and if we are, we call pmc.move to rotate the direction, the target's position, and we call animation controller.setBall moving to true, which basically just controls our moving animation, and then we call pmc.move to position, which is the new one we added, which allows us just to pass in a position to move to, and we move to that. So basically, it's because we got a line of sight, we can basically just move unobstructed in a straight line towards the player. And if we are within 1 unit of the player, we just set moving to false because we don't need to move anymore. If we don't have a line of sight, however, what we do is we call this move along path method, which basically just gets us a path to the whatever Disturb does, so a player, basically. So, first off, we check if the current path is null or the count is 0, then we call getPathToTarget, which will basically just call pathfinding.me.getPath and calls passes in this dot position and the target's position and sets the current path to 0, the counter to 0 because we're getting a new path, so we reset the counter for saying where we are on the path. And then basically we just check if we're within 0.25 of the current path counter, which would probably be vector 2 actually, because that'd probably be more accurate. And vector 2. So yeah, so basically if we are within 0.25 of the current node that we're going to in the path, and then we check if the current path counter is less than the current path count -1, so if we're not at the end of the path, we increment the current path counter, and then that'll allow us to move on to the next point, and so on, so on. Otherwise, if vector2.distance is less than 1 unit away from the target, then we set Boolean, the moving Boolean to animation. Sorry, we use the animation controller to set the Boolean to false. Sorry, what am I doing? Sorry. It's oddly warm for April, so I'm kind of out of it. Yeah. So we get the animation controller, we set the Boolean moving to false to say that we're close to the target, so we don't need to move anymore. If we're more than 1 unit away, so if the player kept moving and we reach the end of the path, we call this getPathToTarget again, so we just get another path, and that'll hopefully bring us to the actual player's position. And then if we're not within 0.25 of the point, we basically just rotate to face direction the current path counter, and we move to position the current path counter, the current node on the path, and we set the Boolean to, we use the animation controller to set the moving animation to true, so we play it. Okay, sorry, fucking this up today, but whatever. And finally, after that, we just call it attack method, which basically monitors whether we should be attacking the target or not. So basically, if attacking is false, if we're within 1.5 of the target, then we set attacking to true, otherwise we just return. If attacking is true, however, we set our attack animation to play by saying ac.setBool attacking to true. We count down the attack timer, and when the attack timer is less than or equal to 0, we do another check to see if we are within 1.5 units of the player that we are currently targeting. Then we get the target's health and deal damage. We set attacking to false, and we stop the attack animation, and there is a lawnmower outside. That's fun. And finally, we just set the attack timer back to 1, so we can count down. It'd be like limited to 1 attack per second. If we are more than 1.5 units away, however, then we just set attacking to false. We stop the attack animation and set attack timer to 1 without dealing damage to the player. Yeah, that's it for the infected behaviour. Now we'll just go on to some of the smaller additions we made. Alright, so next up we just got a player monitor, which is literally just a script that has an array of game objects called the players, and on awake it is set to find game objects with the tag player and store them, and it has a singleton to store a reference to this script. This is basically just placed on the game controller we have here, along with the infected monitor and the item monitor, and basically it just stores a reference to the players, so we don't have to use like find object of type player like every time we want to do a reference to the player. Okay, next up we've done the personal movement script, so we have a bullet. A couple of changes. First change to bullet is that it is now on its own layer called projectile. And the reason for this is so that, if we check the physics 2D collision matrix, we see that projectiles no longer collide with projectiles. So basically what this does is, since bullets now, they both work with physics and get destroyed on collisions, so basically we wanted to make sure that bullets wouldn't collide with other bullets and like accidentally destroy each other. So that's why we did that. And likewise, like the person movement, we've actually changed the bullets to use rigid body dot velocity instead of transform dot translate to move. So yeah, so basically when the thing is created, we set rig dot velocity to be transform dot up times 20 transform, yeah, to basically be transform dot up times 20 to give us the bullet speed. And like before, we have a what's the word? We have a check to see if we are more than 50 away from the start point, and if we are, we destroy the bullet. And we've also got a new collision enter method, which I've just deleted. Which no, okay. So basically, when we collide with an object, we do a check to see if it's got an infected health on it, and if it does, we deal damage of 10 to that infected. And again, if we also check if the object had a player health script, and if it does, we deal 5 because you can have friendly fire in Left 4 Dead. And then after that, we just destroy it. So even if it like hits something that doesn't have doesn't have like any of those scripts on it, it'll still destroy the bullet because it'll like have impacted with a wall or some shit. So yeah. Next up, infected monitor. So we got a list of all the infected in the world, and like we did in infected behavior, this just gets called this static method called add to list gets called in start. So basically, the difference between, if you didn't know the difference between static method and not, and a normal method, basically a static method can only be called by doing like infected monitor dot add to list. Can't call it from here because we're inside it. But yeah, basically you don't reference a specific instance of the class, you just call like the type of the class and then whatever the method is, the static method is. Like we did with singletons basically. And basically what this does is it sets a singleton by finding the object of type infected monitor, and then initializes the list of infected behavior, and then adds the passed in infected behavior to that list. Pardon me. And the next function of the infected monitor is basically just for this disturbance method, which is basically just a way of calling has target been disturbed for all the infected behaviors. So for things that aren't specifically related to like the positioning of one infected versus the player, rather like say if you fired a bullet or threw a pipe bomb or some shit, then this is what you call instead of like the individual infected behaviors, because this can do it for you. So basically it takes the same arguments as this has target been disturbed, and we'll go through each of the infected in the list and call has target been disturbed with those parameters. And I'll just show you where this is called. So basically on our fire weapon, now we have infected monitor.me.disturbance, and we'll basically call it with the transform.root.position. Transform.root will just get the like final parent game object. So in this case, you'll see that how the weapons are actually stored as a child of the right hand. So we'll see we've got a pistol here. The calling transform.root basically will go through all the parent objects of the thing, of the object you called it on, until it reaches one without a parent, and that is considered the root of the object. So that's what transform.root gets. It gets the actual base Zoe object, whatever you want to call it. And then it just passes in 20. It's just a number I pulled out my arse. And then passes in transform.root.gameObject again. just to what's the word? Just to make sure that the player is targeted correctly when if the infected is disturbed. Okay, infected health. Pretty simple. Just an integer saying their health and a method to deal damage to that infected. So it takes away the value passed in. If the value is less than 0, we remove this the infected behavior instance from the list of infected in the world, and we destroy this game object because we don't have like a dead zombie sprite yet. So we'll have to do that at some point. And yeah, that is pretty much it for the episode. So yeah, I'll just go over a quick demo again. So you'll see we've got infected here. If we bump into them, they will get disturbed. We can shoot them, they die. And as you saw there, we can shoot, and that will disturb all the infected, and they will try and attack us. And yeah, they all come and swarm us. And we don't have dying for the player in yet, so I'll have to add that at some point, and Facebook is disturbing me, so I will call that the end of the episode there. So, cheers for watching. Like, comment, subscribe, all that shit. I'm on Patreon. If that is your jam, you can support me, and you get a couple of bonuses for actually doing so. Like, you get early access to the files. I think it's $5 or more. For just $1, you get the files when the project is complete. And for like $10, I think it's, what is it? I don't know. There is something for $10, I just can't remember it. I think it was like a Q&A or something each month where you can just ask me questions or some shit. I don't know. I should probably remember, but I don't. So yeah. And that's about it. Also, a quick plea. If you want to buy Loud or Quiet, I am literally one sale away from getting a payout from Steam because I've only sold 19 copies, which is kind of sad, but whatever. So yeah, cheers for watching and goodbye.